Hi, today I'm introducing the Hamilton application to you. Hamilton is an ontology learning system which can be either used automatically or with a human-in-the-loop component. For the human-in-the-loop component, we provide this application where the system makes automatic suggestions for an ontology based on a relational database, and then the human being or the expert can refine this ontology based on these suggestions. After uploading the database, the first actual stage is the clustering stage. In this stage, the database schema is clustered into different groups of tables. So tables of each topic that belong to each other are clustered within one group. For example, we have here the cities and organizations cluster, we have the continents cluster, or the countries and demographics cluster. And the user can now improve this clustering by drag and drop and changing the placement of the specific tables within the respective clusters. I will now revert everything, but in theory, the user could easily extend here the clustering, or he could also add a new cluster down here by just clicking this button and then using this drag and drop to move the tables around. Next view is then the concept builder. In the concept builder, Hamilton suggests concepts for each cluster. So the system iterates over the respective clusters. You can see this on top. Here are all the clusters. And now we will refine the suggested concepts of each of the tables of each cluster. So we will start with the cities and organization cluster. And here the system suggests two concepts, the city concept and the organization concept. On the left side, we can see the respective tables of that cluster, so city, but also a lot of dimension tables to the table city. So for example, city local name, city other name, or city pops. And we can also see the organization table down here. Then we can see here the two suggested concepts, which would be city and organization in this case. We can now further edit these concepts. For example, we could delete them by clicking delete. Let's do this for organization to show it to you. But then we can also re-edit. So I will edit again, organization. And then I need to add an ID attribute, and I can do this by easily selecting the respective column in the database viewer, which would be the abbreviation in this case. And what you could also do is, for example, add a condition. So let's say we only want those organizations that are located in cities with more than 50,000 inhabitants. For that, we could here click Add Condition. Then we would select in this database viewer again the database column that this condition is based on, so population. And then the system automatically detects that for this condition, a join is required because this is not with the organizations table, but with the city table. So what we are doing is now provide the join that is necessary to perform or to add this condition. So we perform this join. So we join the city column with the name column, and we need to add more joins. We join the country with the country, and another join, we join the province with the province. And then we can click complete join and add the condition. So we select greater than, and we say 50,000, for example. And then we click add condition. And now you can see here that the condition here was added, a reference to the cities table, and also that we have here the left join. All right. And then after we are completed with this cluster, we then click on confirm as suggested, and we get forwarded to the next cluster. And here the system again will suggest two concepts, for example, and we can see on the right side that the two already added concepts were added to the concept overview. After now adding all concepts, or editing and confirming all concepts, we then get to the edit attributes view. In this view, we again get to see all the concepts on the top, and now we will be able to edit the suggested attributes for each concept. On the left side, we again see the clusters that are related to that attribute, as we might have tables that are part of a different cluster. We can here maximize and minimize the respective cluster size, and we can see on the right side then the respective attributes. And now we can again add new attributes here. We can delete the attributes. We can also change, for example, the source attributes. So for example, we could remove the reference to the population attribute and then add another reference again by just clicking in this view here on the left side. So for example, we could click again population. We could also remove it and then add, if necessary, for example, a static value, which would be, for example, 50, and then the static value for the attribute population would always be 50, which doesn't make sense in this case, so I will change it back to population. And then we can do this now for each and every attribute within this cluster. As I said, we can also add new attributes, so let me quickly show you that. We can immediately add a new attribute, which is, for example, another population attribute. Population, click save, add reference, which would be population again. We can also see down here that the system is also able to handle attributes from other tables. So for example, we have here the attribute city local name, so which is an attribute for the concept city, but located in another table than city, so in the table city local name. And here the system correctly identified the join and now visually shows this join also in the database viewer on the left side. And then we can confirm the attributes for this concept and then get forwarded to the next concept. The last stage of the ontology learning system Hamilton is the relationship stage. In this stage, the user sees all the suggested relationships of that specific database or like that are based on this specific database and suggested by Hamilton. And the user can now validate these relationships, refine them, and add new relationships. As the first of all, the last stage of Hamilton is now the relationship stage. In this stage, the user can change and adapt the suggested relationships from Hamilton, as you can see here, and he can also, if we would like to, add new relationships. First of all, you can look at each relationship in more detail by hovering over the relationships, and for example, then see for one of the relationships, let's say we select this one, more details. First of all, again, the concepts, but also, for example, the necessary join conditions that are conducted or created to perform or to create this relationship. As this can become quite a lot, relationships, as you can see here, the user has also possibilities to simplify the load. For example, you can click on the left side on a respective concept, let's say on the city concept, and then the system only shows those relationships where city is part of. So for example, city has a relationship to organization, which is now shown here. The user also has the possibility to use the focused view. In the focused view, the user has to select a specific concept, again, for example, city, and then he can scroll through the respective relationships of city. So he can see all outgoing relationships and also all incoming relationships. For each relationship, he sees all necessary information, he sees the concept, he sees the ID attributes, the name of the relationship, which he can always easily change by just clicking at it. So for example, we want to remove the geographic lake, so just recently call it located in, and he can also see the join conditions that are required to perform or to create this relationship. He could also add a new relationship by clicking on add relationship. Let's say we add one to organization, which is already existing, but just for this experiment or for this demonstration. And then a new relationship is added here. The user has to add this, has to add the name. So for example, located in. And in this case, based on the foreign keys, the join conditions were already suggested. But the user can also edit those by clicking on edit. And then he can now here really change all the information of this join. So for example, you can select another database column. He could select another table. For example, if you have a many-to-many table between two concepts. So let's say city and organization tables have a many-to-many table. Then he could select this here for this specific join. He could also delete a join by clicking on the trash icon. And then he clicks on the check icon. And in the end, he can then confirm this condition. And then, last but not least, after having finished the entire ontology mapping, he can finally download this ontology to use it for later use cases.